we're going to talk about how to verify that two functions are inverses. And here's the rule for that. If you take one inverse and use the other function as the domain, and you simplify it and you get x, and you can do the same composition of the other and you get x, then these functions are inverses. Let me show you what I mean by that. So I'm going to have f of x equals negative 3x plus 6. And then I'm going to have the other function g of x equals negative 1/3 x plus 2. I want to try to tell if f and g are inverses of each other. So I'm going to take the f function and make the g function its domain. And then I'm going to try it where I take the g function and make the f function its domain. And then I'm going to simplify. So I'm going to have the f function, but I'm going to use the g function as its domain. So I'm going to put this in place of f in my f function. And see what happens. It's negative 3 times 1/3 is just 1x minus 6 plus 6. And negative 6 and positive 6 just goes to x. So this side worked. Let's go see what happens if I do the same thing over here. So I'm going to put the f function as the domain. So I'm going to put this in place of x in the g function. Negative 1/3 times 3x is just x. Negative 1/3 times 6 is negative 2 plus 2. Those cancel and I just get x. So since this one simplified and got x, and that one simplified and got x, these must be inverse functions. So I could say that f of x, if that's this one, I could have named this one f inverse of x, because that's exactly what happened. Let's do one more. Let's do 3x cubed plus 1. Let's start off and see if we can actually find the inverse of this one. So I know that it's a function, f of x equals 3x cubed plus 1. I'm going to see if I can find the inverse. So I'm going to start by switching the x and the y, and then I'm going to solve for y. So I'm going to subtract 1, and then divide by 3. And then to solve for y, I'm going to cube root both sides. So this would be the inverse function.